All right, if you're an AI architect or a developer working with RAG systems, you need to listen up. There's a massive shift coming, and it's going to completely redefine what high-fidelity retrieval means by 2026. We're moving way beyond just simple text now, and honestly, the old rules just don't apply anymore.
And this quote right here, it just hits the nail on the head. It perfectly captures this tension we're all feeling. Chunking, right? The thing we do to make AI smarter by feeding it bite-sized pieces of information? Well, that very process is now becoming a massive bottleneck. It's turning from a simple, boring pre-processing step into a critical point of failure in today's RAG systems. So what's actually going on here? Well, we're in the middle of what you could call a RAG context crisis. See, as big companies are really starting to use RAG systems for real-world applications, they're not feeding them clean, simple text anymore. No, they're throwing everything at them. Technical manuals, financial reports, real estate listings, you name it. And our old, trusted methods, they're just completely breaking down.
Yeah, I'm talking about really complex multimodal data. Think about it. Technical manuals with these super intricate flowcharts. Financial reports just packed with charts and tables. Or, a real estate listing where the picture of the house is arguably more important than the text describing it. This isn't a future problem. This is the reality of enterprise data right now.
And this table really lays out the fundamental problem. On one side, you've got uniform chunking. It was great, designed for plain text, for novels. It loves a simple, predictable, linear flow. But on the other side, you have this messy, real-world multimodal data. When you try to force that complex mix of text, images, and tables into that old rigid structure, it's a disaster. It's like trying to fit a square peg in a round hole. You just end up shredding the context and losing a ton of critical information.
Okay, so let's get into the weeds a bit. How does this failure actually happen at a technical level? Because this is where the real engineering headache starts.
The core problem has a name. Context fragmentation. Just imagine you've got a detailed schematic and a technical manual, and right next to it, there's a paragraph explaining exactly what every single component does. Now your dumb, rigid 512 token chunker comes along. It doesn't see a diagram in its explanation, it just sees a bunch of tokens. So what does it do? It takes a butcher knife and slices the document right between the two, completely destroying that crucial link. The meaning is just gone.
And that brings us to the multi-million-dollar question for any data infrastructure architect out there. So, how do you embed a complex diagram? You can't just shove an image through a text embedding model, that doesn't work. But if you just ignore it, well, your RAG system is essentially blind to what might be the most important information in the entire document.
Okay, but there is a fix. A really elegant one, actually. This is where vision language models enter the picture. And trust me, this is the solution we'll all be using by 2026.
So the key technology here is the vision language model, or VLM for short. And these things are kind of magic. They can genuinely see and read at the same time. They can look at an image, a diagram, or a chart, understand what's going on, and then describe it perfectly in plain English.
So here's the play. This is the modern engineering fix. Instead of trying to force a square peg into a round hole, you use a state-of-the-art VLM. We're talking GPT-4o, Claude 3, and you have it look at the visual element. Its job is to generate a rich, super detailed text description of what it sees. And the process is actually pretty straightforward. First, the VLM ingests the visual. Could be a flowchart, a photo, a graph, whatever. Second, it generates a really meaningful semantic description. Not just bar chart, but something like, this is a bar chart showing a 30% jump in Q3 revenue, which was driven mostly by the North American market. See the difference? And then finally, you take that new text description and you package it all together with the original text and all the metadata. What this process does is create something totally new. It's a brand new data primitive for RAG systems. We're not just chunking text anymore. We're now creating what we call unified multimodal chunks.
So what's inside one of these new unified chunks? Well, it's got the whole shebang. You've got the original text that was right next to the image, you've got the brand new VLM-generated description of the visual, and you've got all that rich metadata. The source document, section headers, page number, all of it. The result? You get a single, semantically complete unit that is just perfect for retrieval.
And here's the absolute key takeaway. That big problem we talked about, context fragmentation, solved, gone. You're no longer just embedding the text and kind of hoping for the best with the image. No, you are embedding the meaning of the image, translated into text right alongside the text that describes it. The entire semantic meaning of the original document is kept perfectly intact.
Okay, that all sounds great in theory.
But what's the real-world impact? How does this new architecture actually perform in a production system where, accuracy is everything?
Well, look no further than an industry like real estate. It's a perfect example. A property listing is a total mix of stuff: text, photos, data. With this multimodal chunking technique, a user can search for something like a 3-bedroom house with a modern kitchen and a big backyard. Now, the system can match that query against both the text description written by the agent and the VLM's description of the photos. Suddenly, you get a single, incredibly relevant search result.
And the numbers don't lie. The results are, well, they're dramatic. We're seeing case studies in fields like legal tech and e-commerce reporting up to a 30% improvement in retrieval accuracy. Let me say that again, a 30% improvement. That is a massive leap in performance. That translates directly to more accurate, more reliable, and frankly, more useful AI systems.
So, that brings us to one last big question to leave you with. This whole unified multimodal chunk idea, it's a huge step forward for sure. But now that our AIs can genuinely see and read context together as a whole, what comes next? What are the new data structures and retrieval architectures that this is going to unlock? Honestly, that's the big challenge for 2027 and beyond. So my advice? Get out there, start experimenting with this in your own projects, and let's see what you can build.